So once we have done matrices, today we will do determinants, and this will, after this chapter, your algebra portion will end and we will get into calculus. Determinants. Again, an easy chapter, all about calculations. Unless and until you do mistakes in plus and minus, you should not be ending up in trouble in this. Very easy chapter. Okay. Now, how does determinants come up? We say that matrix is an array of numbers, and a matrix does not have any value. A matrix does not have any value. So the prelude to this chapter is, if you have a square matrix, and this can be of any order, right? This can be of any order. The order that we will be dealing with most will be order 2 and order 3, but it can be order 1 also, order 2 and order 3. Children, this is not that it has to be of this order, it can be of any order. Every square matrix you can assign a value. And depending on the type of the matrix, if your matrix is actually a real matrix, then you can assign a real value. If it is a complex matrix, then you can assign complex value to it. Okay, a value, and this value is known as the determinant. In many books it will be denoted by triangle. Determinant will be denoted by triangle. Is this much clear? A matrix does not have a value, but a matrix can be assigned a value. The matrix can be a order 1, order 2, order 3. In our syllabus, we will be dealing more with order 2 and order 3. That's why I have written that. It is not that it cannot be of order 1, because order 1 you hardly have any calculation. You can assign a value to it, and that is known as the determinant of it. Let's see it a little bit more in practice. Okay, let's go to grade 10. Let's go to grade 10. In grade 10, you had a chapter called linear equations in two variables, and you had equations. Let's say I have equation a1x plus b1y plus c1 equals to 0, then a2x plus b2y plus c2 equal to 0, right? And we could solve them algebraically as well as we could solve them graphically. So depending on type, we said that you can either have unique solution, that is, or you can have what is known as infinitely many solutions, or it can be that you have no solutions at all. Time for us again to check the names. Okay, if you have a unique solution, then you used to call it a consistent system of equation. If you had infinitely, then you said it is consistent but dependent. Okay, this is dependent, and this one was known as inconsistent. Okay, if you solve it graphically, you would get lines which would intersect only once out here. Infinitely means two lines will coincide upon each other. We also call them coincident. The lines will be coincident, and here the lines would be parallel because they don't meet with each other, each line corresponding to one of the equations out here. Now what was important is, let's revisit the criteria. Here we used to say a1 by a2 is not equal to b1 by b2, right? And here we used to say that a1 by a2 equals to b1 by b2, right? And what was this? Infinitely many. Okay, so this will be equals to c1 by c2, and here we had a1 by a2 equals to b1 by b2 not equal to c1 by c2. These were the criteria, right? Let's concentrate a bit on this criteria. This is just to build up the idea for what you call determinants. If you wanted to have a unique solution, you created the criteria that a1 upon a2 is not equal to b1 upon b2, right? Being an inequality, let me cross multiply. I get a1 b2 is not equal to a2 b1. Is this understood? And let me bring it this side, right? I can write a1 b2 minus a2 b1 should not be equal to 0, right? From here, the birth of determinants takes place. So Zoe has come. The birth of determinants takes place. Actually, we can put all these things in this manner. Let's make a square matrix, and in that square matrix, let us put A1, B1, A2, B2. Got it? A1, B1, A2, B2, and then we can actually put a square matrix XY. This is what you will be getting, and this will be equal to say C1 and C2. This is what will come up. Don't bang your head on this. Now, this relation is more important to us. This relation comes from setting up a determinant. The determinant is A1, A2, B1, B2. This is called a determinant. The determinant of this is actually the left hand side. Have you understood? This you don't bother right now. Just bother on the criteria. You said A1 B2 minus A2 B1 should not be equal to 0. In other words, I will say determinant of the matrix of a matrix which is like A1 A2, huh? Oh, video has gone away. Right. 1 minute, huh? Oh, why did I stop the recording? 1 minute, huh, child? Just one. No, this is a problem that the handycam goes from a charge mode. That's why this happens. Nobody touched it. Are we fine now? Okay. Where did you lose the video signal, Ananya? Just tell me. Just now. Okay, fine. So concentrate on this part. A1 B2 minus A2 B1 should be equal to 0. Should not be equal to 0. This term can be expressed in the language of determinant, where we say the determinant of a matrix which is like A1 A2 B1 B2. Right? The determinant value of the matrix. Now, what is determinant value of the matrix? We will actually put let's put it like this. Let's say the determinant value of a matrix of a A1 A2 B1 B2. Here we just put straight line. This value should not be equal to 0. This is what we mean by determinant. So what are we doing? If you see, we are multiplying A1 B2 and we are subtracting the product of A2 B1. Right? This is easy because now you are seeing it as a 2 by 2, a matrix of order 2. So let's revise once again. What do we mean by determinant? Once you have a matrix, you cannot assign a value. Every matrix can be assigned a value based on the type of the matrix that you have, and that value is known as the determinant of the matrix. Right? In order to understand determinant of the matrix, it is most widely used in solving linear equations. This is linear equation in 2 variable. If you were with what you call additional mathematics in commerce section, they will have linear equations in 3 variables. There is a rule called Cramer's rule. They will have x, y, z. And so in order to solve with number of variables, your number of equations should be equal. I hope you know that. If you have linear equation in 1 variable, 1 equation is sufficient. If you have 2 equations, you need 2 variables. If you have 3 variables, you need 3 equations. So here we are going to solve, say, 2 equations. So I just recall what we had studied in grade 10, and we bring out the criteria for unique solution. In unique solution, we say A1 upon A2 is not equal to B1 by B2, which can be then transformed as A1 B2 minus A2 B1 is not equal to 0. You just cross multiply, bring it this side. How do you express this particular statement on the left hand side? That is expressed by the word determinant. This is determinant. Okay? It's called.
So the determinant of any 2 by 2 matrix cannot be equal to 0.
No, not that. We have not gone into determinants at all. This is where, what is the definition of a determinant? What is the definition of a determinant? In order to make you understand that a determinant, say for example, beta, I have a square matrix A1, A2, B1, B2. Then I can calculate the determinant of A, which is given by A1, A2, B1, B2. Do you understand, Ananya? The determinant of A is the crisscross subtraction of product. A1 B2 minus A2 B1. This is what in plain language determinant means. Have a square matrix, you can assign a determinant, and then you can calculate a value out of it. Sir, show me some use of it. Well, in grade 10 you used to prove this criteria. So in this criteria you used to show that A1 by A2 not equal to B1 by B2. Now in grade 12 I can say that a system of equation like this can be consistent or have a unique solution if the determinant value is ultimately this, not equal to 0. That is one use of determinant. That is one use of determinant. Is that understood? Okay. Now we will see how determinants are classified and how do we calculate the value of a determinant. In this chapter, you have to understand how to calculate value of determinant. Today we'll see that. Then we'll see how to calculate area of triangle if the vertices are given. After that, we will get into next class maybe something called cofactors and minors. Then we will calculate what is adjoint of a matrix and all. All are very easy. So let's get into finding out determinants. We will get matrix. We will convert them into determinants and find out value. That's our job. Right. Can I go ahead? Ananya, this thing got cleared, right? This confusion of yours. This has nothing to do. This is one application of determinant. Okay. All right. Let's see. Let's recall something called order of matrix. Order of square matrix, because determinants can only belong to square matrix. So your life becomes a little bit easy right by the word square. Right? We can have order 1. A square matrix of order 1. Just imagine how it will be. It will be only one element. Say A. So in this case, if you want to calculate, let's say this is our matrix. If you want to calculate what is the determinant of A, what more can I do with it? I have no option to do anything. Is this understood, Ananya? Right? Now let's go to order 2. Order 2, and now my matrix is, let me just make this a little bit, write it properly, okay? Let's say order 1, your matrix is A equal to A. In this case, your determinant of A would be only A. Right? Let's say we take it order 2, where my matrix is now A1, A2, B1, B2, typically like the matrix that you had. Understood? Such a matrix, the determinant value will be given by det A, which is you multiply A1 with B2, A1 B2 minus A2 B1. Have you understood these two? And these two are very easy. Hardly anybody will give you problems with these two. These are very easy. They don't eat your head much. Okay. Let's say we take an example based on this. Let's say you have 2, 4, 1, 5, and here you have something like 2x, 1, 3, and say 2. Let's solve this. Finding the value of x, shall we? So how do we solve it? 2 multiplied by 5 minus 1 multiplied by 4 should be equal to 2x multiplied by 2 minus 3 times of 1. Right, kiddos? So this becomes how much? 10 minus 4 is equal to 4x minus 3, which makes it 6 plus 3 is equal to 4x, or x is equal to 9 upon 4. That's how we arrange indeterminants. Right, ready for the main part? Okay, let's start. Okay. You just need to give attention and understand once. If you have understood once, your job becomes easy. Just try to understand once. Order 3. So A as a matrix will now be A1, 1, A1, 2, A1, 3, B1, 1, B2, 1, B2, 2, B2, 3. Or let's keep it only in terms of A, then your job becomes easy. A2, 1, A2, 2, A2, 3, A3, 1. You don't need to first know the meaning of the word I and J. I stands for row, J stands for column. Okay. Now we have to find what, beta? We have to find the determinant of A. Now your first job should be express this matrix as a matrix of, in your mind you should think like this. In your mind you should think how to make it in order 2. Because once you make order 2, your life becomes easy. Right? But this is order 3. How to make it order 2. Right? Now, there are some positions. Look at this element. Look at this particular element. What is the I plus j? You try to calculate what is I plus j value for every element. And when you calculate I plus j, just have two things in mind, whether it is even or odd. Nobody is interested in the value, whether it is even or odd. I think here it will be even, odd, even, odd, even, odd, even, odd, even. Did you understand what I tried to say? If you pick A1, 1, then the value of I is 1, j is 1. 1 plus 1, 2. This will become 1 plus 2, 3. So one thing is understood. What is that thing? No matter what matrix is given to me, this is always an even, odd, even. Then what happens to this? Odd, even, odd, even, odd, even. This thing you need to keep in your mind, right? And we will bring one scalar multiple which is -1 to the power I plus j. Don't bang your head. Just see. I will read this as -1 to the power even or -1 to the power odd. Values cannot be more than that. Right? Either the values will be even or the values will be odd. If the values are even, then -1 takes the value 1. If it is odd, it takes the value -1. Is this understood? And this -1 will be associated with every element. Every element. Whether you use it or not will depend whether you are taking, you are expanding from that element. What is expanding from that element? I'll explain you. So what did we understand? The -1 to the power I plus j will be associated with every element. Whether I will use it or not will depend how I'm expanding the determinant. Right? Now, first question. If you pick up this element, then the -1's value will become 1, -1. Then here 1, -1, 1, -1, 1, -1. Agreed? Okay. Let's understand the easiest way of expanding a determinant. The easiest way of expanding a determinant is pick up this element. Pick up this element. Right? As you pick up this element, do one operation in your mind. Look at me. Which element did you pick up? A11. Close the row, column, and close the row. Do you see a square matrix? You see a square matrix. You could have opened it up using this one also. Right? Now, I will mutate this figure. If I'm using A11, then these are cut off. These are cut off. Do you see a square matrix? You do. Fine. If I pick up this element, this is cut off and this is cut off. Is there a square matrix? Tuck, 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 tuck. there's a square matrix. Okay, fine. Now I think you're getting the idea. If you pick up this is gone, this is gone. Is there a square matrix? Yes. Okay. Nobody stops you from picking any element of your choice. Sir, I would like to pick this element. Please go ahead. Do you see a square matrix? Yes. I hope by now you have understood. Any element you pick, you can pick this element, whichever you want. Sir, which element should I pick? That I'll tell you a little bit later, right? So let's go by the basic way. So the basic way would be, I'm going to expand it by row. I'm going to expand it by rows, okay? There are 6 ways to expand actually, 3 by rows and 3 by columns. I'm first going to expand it by row, and for simplicity, I will use the first row, right? So when I use the first row, I would be picking up this element, right? If I pick up this element, children, this and this is ruled out. Do you agree? Come on. So I write -1 to the power 1 plus 1. Why did you take 1 plus 1? Because the I value for this is 1. The I value for this is also 1. I will not write it so much detail. I think you understand that for the first element, the -1 will not hold. It will become +1, right? But the idea is to do it like this: -1 to the power 1 plus 1, A11, right? And form the square or determinant A22, A23, A32, A33. Have we understood? Right? Children, which way I am expanding it? I am expanding it by row. Which row? First row. So what should be my next element? A12, right? Then I add again a -1 to the power 1 plus 2, row 1, column 2. In next step onwards, you basically understand plus, then minus automatically. Okay, come children. My next element is this one. This one is my next element. I have cancelled this, I have cancelled this, right? So I'm left with what? I'm left with A21, A23, and A31, A33. Agreed? Now I should go to my third element because I'm expanding it by row. So I go to my third element, which is A13. So now this is ruled out, this is ruled out. So once again, I will put my addition sign -1, first row, third column, and it is A13. So definitely one column. Now see, you did not look into the determinant. Look, you can do it from here. 1 means first column ruled out. 3 means, sorry, first row ruled out. 3 means third column ruled out. So you will be playing between column 1, no, column 2, column 1, column 2, row 3. Okay. So row 2, A2, and it will be A21, A22, A31, A33. That is the value of this determinant. Sorry, A32. That is the value of this determinant. And you know how to solve them. So what does it become? It becomes A11, A22, A33 minus A23, A32. Then it becomes minus, oh, I did not add the number. This was A12. A12, A21, A33 minus A23, A31. Fine. And this again becomes plus A13, A21, A32 minus. That's it. That is the determinant value. Right? Any doubt, Ananya and Zoe? Any doubt? Both of you? Understood? Right. So it now looks that they're going to eat up our head in all this so much of calculations, right? And look, if I make these numbers now 56, 43, 31, 28, your life becomes miserable. How can we make it easy? Just imagine if this number would have been a 0, this entire term becomes 0. If this number would have been a 0, entire term becomes 0. Therefore, I told you how to expand. I will explain you later. Expand by the row or column that has the maximum number of zeros. Did you understand? So what I'm trying to say, with the, again mutating this diagram once again, say suppose children, this particular entry was a 0 and this particular entry was a 0. You will be a fool if you expand by this row or this row or this column or this column. This column still a less full. You will get 1 0. I will expand it by this row, because then my first term will become 0. My last term will become 0. I have to take care of only the middle computation. So you remember in matrix, something that was taken off was the elementary row conversions. So elementary operations are there in determinants also. And by doing that, what we do, we reduce the determinants and bring as many zeros as possible. You can do it without doing elementary computations. Well, maybe it's not there in your syllabus now. But if elementary operations were allowed, you can make as many zeros that you want and then start doing the determinant calculation. Life becomes easier. Is that understood? Right. So if you have understood this, okay, before going to our next topic, there are some properties of determinants. So you can write down, if you interchange rows and columns, okay, this is again elementary. I'll leave it now. We'll not discuss this. We'll not discuss this. Let us see whether this comes up in our topic or not, and then leave it. We'll do. Okay. So let's get on with some calculations of determinants or based on what we have learned. This is task for you. Okay. Okay, the task is evaluate the determinant. Evaluate the determinant where the determinant is equal to this is the determinant. Tell me, how will you like to expand this determinant? I will like to expand it by the third column. That would be my easiest, right? So I write my determinant value is, I take 4. Children, position. 4 is always a positive number. Even, odd, even. So 4 will always be positive. 4, and then you have negative 1, 3, 4, 1. Then we have a negative 0, and obviously I'm writing still 1, 2, 4, 1, and then I have a positive 0, and with the positive 0 I would be having 1, 2, negative 1 and 3. Now do you see how easy the determinant calculation becomes? So determinant is equal to 4 multiplied by negative 1 into 1 is negative 1 minus 12. So this becomes delta equal to 4 times negative 13, which is equal to negative 52. Fine. Let's take one more. Evaluate the determinant delta equals to 0 sin alpha and cos alpha negative. Okay, sin alpha, cos alpha negative, negative sin alpha 0, cos alpha. Okay, sorry, not cos alpha, sin beta. Sin beta. Cos alpha negative sine beta 0. That's a diagonal. How will you like to expand it? You have no choice. The best is to go by the first row. Easiest way. So let's go by the first row. Okay. Can I take off this portion? Make it a little bit smaller. Okay, let's do this. The determinants equals to 0. Obviously, we are not expanding any further. All right. And then I have a negative sine alpha. And negative sine alpha will give me negative sine alpha, sine beta, all right, cos alpha 0. And then positive and negative, so it will be negative cos alpha minus sine alpha 0 cos alpha minus sine beta. Right? So determinant now equals to, well, let's see this. This is negative sine alpha, which will be a 0 minus sine beta cos alpha. Fine. And here we will have negative cos alpha, and it will be sine alpha sine beta. Paka bacha? Okay. So we get negative multiplied by negative is a positive. So we get sine alpha sine beta cos alpha minus sine alpha sine beta cos alpha. Finally, our answer is 0. Yeah, satisfied answer. Okay. Now we come to properties of determinant. Shall we? Okay. Let's study area of triangle. Acha, tell me, recap. Do you understand now how to calculate a determinant? Yes. And what should you use? Expand by the row or column which has maximum zeros. Your job has become easy. Come, your next topic. Area of a triangle. Area of a triangle. Very, very easy, unless and until you goof it up with calculation. Area of a triangle. A triangle is given to me with A, B, and C. This time we will go by the vertices. X1, Y1. This is in coordinate geometry. X2, Y2. X3, Y3. Children, here only the order matters. You need not draw your triangle like the quadrant where it should be and where it is not. Just make sure that the order is correct. Now look how you need to write this formula. Look. Okay. Now, depending on what order you take, you might come up with a positive value or a negative value. But area is always positive. So area is given by, area is half base into altitude. Okay. Pay attention here. How to write the formula. Half, we put modulus, means whatever the calculation will come out, irrespective of my mistake, the calculation should always be in such a manner that positive values are given. Half modulus. Look what I'm doing. X. I've given a space y minus y. Okay. Plus again x. Y minus y. Observe, I'm leaving some space. Okay. then plus x y minus y. Just write this. This is possible. Right means just enjoy. This much first we will write. Agreed? Then make one triangle. Sorry, one circle. And make the logo of Mercedes-Benz. And you write 1, 2, 3. Just like a Mercedes-Benz logo. 1, 2, 3. Okay? Now you move in this order. Move in this order. Start from 1 and move in this order. Start from 1 and move in this order. So what do I get? 1, 2, 3. Now go to 2 and move in that order. 2, 3, 1. Then go to 3 and move in this order. 3, 1, 2. That's all. You cannot make a mistake in this order. Did you understand the trick? 1, 2, 3, 2, 3, 1, 3, 1, 2. So if you want to write this in matrix form, sorry, determinant form. So you have a y2 minus y3. Just see. I should be having an x1 out here. Okay, try. And if I expand it, I should get this as the 2 by 2 matrix. Y2. So my y2 will be somewhere here. It multiplies the third element, but it's still y2. So I'll put a 1 out here. Right? And I will put a y3 here and I'll put a 1 out here. Just check. x1. Then what do you get? y2, 1, and this. y3. Okay? In my next one, I have a x2. Sorry. I will have an x2 out here. Now just see. But x2 starts with negative. x2 starts with negative, okay? So it will be something multiplied here. Something multiplied here. So if I put a y1 out here, it's a y1 y1 into 1 is y1 minus y3. But since there is a negative out here, this has got swapped. Neha, you didn't see. That's why I always say keep your eyes on the board. Try to understand the logic, how to develop the determinant. Okay. Now look here. This is the 2 by 2 matrix. Your x2 is at this position. If I bring y1 here just by symmetry, got it? And I put a 1 out here, let me see. x2 multiplied y1 minus y3. But this is y3 minus y1. Because x2 is a negative entity. Look at the I plus j value. This is negative. If you take a negative, see, ultimately it should have been something like that. x2 multiplied by y1 minus y3. Do you agree or not? If I take minus 1 out from here, so it is minus x2 into minus 1 into y3 minus y1. This minus and minus makes it plus y3 minus y1. Is this not the same thing here? So what should you put here? x3. This is the area of a triangle in determinant form. So you have to mug it up. x1, x2, x3 in vertical, y1, y2, y3 in vertical, 1, 1, 1 in vertical, and then this is the way you expand it. Any confusion on area of triangle? These are easy to learn and easy to forget topic. Once again, I'm saying very easy to learn and very easily you will forget these also. Fine. So let's do one. Find area of a triangle. Find area of a triangle, and let's see what the vertices are. The vertices are 3, 8. Okay, and then -4, 2 and 5, 1. 5, 1. So you can write, let x1, y1 be 3, 8, right? Just for clarity purpose, x2, y2 be -4, 2 and x3, y3 be 5, 1. If you want to show it in determinant method, then how do you write the area as? The area can be written as half into the determinant. What is the determinant? x1, x2, x3. 3 -4, 5. 8, 2, 1. 1, 1, 1. This is your determinant. And if you want to write it in the expanded form, then you would write area is equal to half. And I always say that it is something like this plus this plus this, right? So let's bring out. It should be 1, 2, 3. 1, 2, 3. So it will be 1. Then here it will be -4, and here it would be 5. Then 1, 2, 3. 2 minus 1. Then 2, 3, 1. 3 and 1. So 1 minus 8. And then if you take 3, then it is 1 and 2. 8 minus 2. Which is equal to half. Modulus 3 multiplied by 1 is 3. -4, and this is -7. -4 minus 7 makes it plus 28. And this is 2, that is 6. 6 plus 5 is 30. So you get half modulus of 58, right? 59, 60, 61. The answer comes 61 by 2 square units is the area of the triangle. They can also give you problems in which area will be given and one vertex will be absent. One vertices will be, one coordinate will be absent. Shall we do one of that type? Okay. And by that we can conclude, so that we have done area in this, and next class we will go to, I think 3 classes, this will be over. Okay. But you need to do your first 2 exercises. So see, the language is tricky. That's why I will write the question. Okay, the language is tricky. So let me write the question. Find the equation of line joining A 1, 3 and B 0, 0 using determinants and find K if D K0 is a point such that area triangle ABD is equal to 3 square units. Is 3 square unit. First you need to find out area line joining 2 points. I don't know how nice you studied coordinate geometry. Okay, let's see, this is B00. This is called 2-point formula. You need not remember anything at all. Coordinate geometry, straight lines, you need not remember any formula, just some basics. In order to find an equation, we will always put a tester point on this line, which will be a point Pxy. Agreed or not? The Pxy dances along this line, right? The slope between this to this and this to this should be same. What is slope? Y data over x data. So let's calculate the slope here. Y minus 3 divided by x minus 1 should be equal to the slope out here. Now, how did you do the slope in this one? This minus this, y minus this. So here also we will follow the same way, and it doesn't make any difference. You would have done y minus 0, then also the answer will come same. You get it? Just make sure that you follow the same order. So it's 0 minus y followed by 0 minus x. Children, if I would have done y minus 0, then also it doesn't make any difference, because if you do y minus 0, do x minus 0 at the bottom. So this is same as, I can write it as y upon x. Clear? So what is your equation? Xy minus 3x is equal to xy minus y. Correct? So xy cancels. Y minus 3x equal to 0. This is the equation of the straight line. Very easy. Did you understand how we found out? Slope is same. And further it says that we have a point D out here. And D has the equation coordinate of K0 and the area is given. So you have to find out what is the coordinate K. Pakka? Let's find out the area. 3 square units should be equal to half, right? Again, bracket plus bracket plus bracket this. Acha, which way are we moving? We'll take this as x1, x2, x1, y1, x2, y2, x3, y3. Right? So first we put what? x1, and then we put y2 and y3. So it will be 0 minus 3. Then we put x2. x2 is 0. So no need of calculating. Whatever it is, it will come 0 only. And then we put x3. x3 is what, beta? 1. And if you put x3, 3, if it is 3, 1, 2. So 1 and 2. So this portion is also gone. These two portions are giving you 0. Right? So 3 is equal to half k into minus 3. Agreed, children? But this is in modulus. Okay. So we can write 3 is equal to 3k by 2. Okay. So 3 and 3 cancel. K equal to 2. Now there is a catch out here. Look, there's a catch. K's value, even if it is 2 or K's value, even if it is 2 or negative 2, it doesn't change, because end of the day you will get a modulus out here. So if I would have solved it with minus 3 also, it is allowed. If you solve it with plus 3 also, it's allowed. So K can take the values of plus minus 2. Did you understand how the equation part came up? So your homework will be exercise 1 and 2. Your 1 and 2. One is area exercise and the other exercise is your yeah. see, at this stage we can say modulus of something is equal to 3. So even if it was, this thing could have been a plus value, this thing could have been a minus value. So from here you get negative 3k by 2 is also equal to 3, and actually positive 3k by 2 is also equal to 3, because it's modulus. So if you solve this, you get k is equal to negative 2. If you solve this, you get k equal to 2. So you write k equal to plus minus 2. Fine. So do these two, very easy. First exercise is all about expanding determinants. Second exercise is all about finding area of triangles. When you find area of triangle, you are free to choose. There are two ways you can do. Either you do it this way. If you do it this way, it becomes more cumbersome. The best way is when you expand it in this way. And for that, remember this chronology. Okay. On our next class, we'll do minor cofactor and then we go to adjoint.